Welcome back to part 2 of binomial coefficients, lesson 10.5. This is the part where we're going to expand the binomial expansion and the coefficients in that we are going to go beyond Pascal's triangle. You are not going to want to sit and always have to expand that triangle every time, let's say you have an exponent of 10 or 12 or 20 or any high number. You don't want to have to sit there and draw the triangle out and then look at each term. So there is a shortcut, and I'd like to talk to you about this pattern. So this is similar to what we saw before, a plus b to the n, where you have a first term that doesn't have a coefficient. Remember, it's got a 1 there. The second term has a coefficient, and the last term doesn't have one, and the second to last term is going to have the same coefficient, right? And then there's the pattern inside. Well, what we've determined is that the coefficients for every term are combinations. And this combination of NCR, right? There's a little n, big C, and an R, and that's a combination of n things taken R at a time. Now, you've done this before when you did probability and when you did permutations and combinations. So that n combination of n things taken R at a time can be worked out with this factorial. Factorial of n divided by the difference between n and R factorial times R factorial. Now, you can review this factorial. You can do that out longhand every time. I will allow you to also use your calculator, and I'm going to show you how to do that. We also denote it by putting really big parentheses, and we put n and we put the R. That, you see that symbol, that means a combination of n and R. That you don't draw a line, you don't make it a fraction, you just make a big parenthesis with n and R, and you know that that means a combination. Let me review the steps to put that in the calculator. So let me write this down. Calculator, you have to enter the n first. So you're going to put in whatever that n number is. Then you're going to go to Math, and you're going to go all the way over to the right, and you're going to select PRB. What do you think that stands for? It's the probability, right? Probability menu will come up, and you're going to select number 3, which is going to be the combination. You're going to select that, and then you will see the NCR pop up on your screen. So you have the number, the n, then you'll see NCR, and then you enter your R value. Then when you hit enter, it will give you this factorial solution. It does the math for you, which is very nice, and I will allow you to do that on the quiz when you take your assessment. If you have trouble remembering and you want to practice your factorials, you can do that in the front of your book in the 0 chapter. They do some reviews of things that you should have already remembered, and you can review your combinations and factorials on page P28 through P30. Now, when you do the combination, if you write the coefficients this way, then your coefficients simply become these combinations. Now, if you'll notice, my A's and my B's have not changed. But the first term, the n term, is this exponent. And that is going to be the top, the combination term in every single coefficient. And then the bottom term becomes the that value, like this is the 0 term, that's the first term, the second term. Then it goes to R, and then it repeats again. The last term is going to be the nth combination of n things taken at n times. So when you do this combination, the combination of with 0 down there, you will get 1. And that's why we start at 0 when we have the nth term, because we know the first coefficient is always 1. Let's try one. I think you'll see when we do this expansion how easy this is. I started one here. I'm going to go back and do example 1 again so you can see how this works. So we are going to do a plus b to the 6th again. So the coefficients are going to be the 6th is the n, and then I'm going to have the coefficient will change. This is 0 the first time, that's 1. The next one, let's see, let me get my colors going. All right, the next one will be 6 and 2, and my A's are decreasing, my B's are increasing. The next coefficient will be 6 and 3, A cubed, B to the first power, cubed, right? Because that needs to add to 6. And the B's are going up. The next term, coefficient will be 6, 4. This will have only 2 A's and 4 B's. Next coefficient is 6, 5. Has only 1 A and 5 B's, right? 1 plus 5 gives me 6. And the last term will have a coefficient 6 and 6, and that is B to the 6th. Let's, for example, let's just look at this one right here. If I take the 6, the combination of 6 and 2, if I wanted to look at that with the factorials, that would be 6 factorial over 6 minus 2 factorial times the 2 factorial. If you don't remember what that is, that means 6 times 5 times 4 times 3 times 2 times 1 over, that would be 4 factorial, so 4 times 3 times 2 times 1 times 2 factorial. And then you simply reduce and simplify that, and you have all these things you multiply. I could take the 4 down to the 1, simplify that, and this is 2 into 6 times 5, which is 30. That's going to give me 15, right? That's 3, that's going to give me 3. That's going to equal 15. That's just the coefficient. So that means that that is 15 a to the 4th b squared. Okay, 15. Go back up and look at example 1 and see if that's what we had. Sure enough, that's what came off the triangle. Okay, so this is just another way to do it. This is very quick also in the calculator, all right, when you want to do that. So we will do that on another example. Just a second, let me get that set up. I want to go back and point something out real quick on example 1 here. First of all, I said I was going to use 4 colors of highlighters, so let me do that real quick. Let's look right back up here at example 1. I want to point out that we have 6, n is 6, but how many terms do you have? 1, 2, 3, 4, 5, 6. You have 7 terms. Remember, you have n plus 1 terms. Now, I also want to point out that if you're playing with the first term or the second term, the third term is going to be 1 more than the b exponent. So if I want to know the third term, I need to take 3 minus 1, and that will give me what the b exponent is. The fourth term, the b will be 1 less than that. The reason I point that out is I'd like to try this example right now. I'd like to find the coefficient of the third term of a minus b to the 13th. Now, you don't want to sit and do Pascal's triangle out 13 rows. So we're going to do our combination shortcut with the binomial theorem. So here, if the third term is, remember you're going over 3 terms, that means that the b is going to be 1 less than that. All right, I'm going to have 3 minus 1, which gives me 2. So that 2 is going to be the b exponent right there. That 2 comes down and is right there. If the b is 2, a is going to be what if it has to add to be 13? It's going to be 11. Because 2 plus 11, remember, has to equal what? Has to equal my n, which is 13, right? And that number goes right here. So when you add those, that equals the number that goes up here on the top. This number down here is that number. Now you're going, Miss Reams, I don't understand what that is, but let me show you how easy that is. All you want is the coefficient of the third term. So you have figured out that the third term is going to be a to the 11th b squared. And this coefficient right here is very easily determined with the combination. So let me show you how we do that. Remember, we first put in the n, so I'm going to first put in 13. And then I'm going to hit math, and I'm going to come over here to probability, and I'm going to come down and I'm going to select number 3, which is the combination. And then, you see how I put that up there? And then I'm going to put my R value, which is 2. And I hit enter, and it gives it to me. It did the factorial work for us, and it says it's 78. So that means that the coefficient, I've got all these other terms here. This is going to be 78 a to the 11th b squared. But the coefficient, and I'm going to have other terms over here, but the answer, what I want is the 78. I only wanted the coefficient for the third term. Let's try another example. Find the coefficient of the x to the third, y to the fifth term of this expansion, 2x minus 3y to the 8th power. Well, let's look at some things we know here. Here, I already know these exponents, which is really nice. So I'm going to write that out. I have the x term, which is 2x, and I have 3 of them. The y term, I have 5 of them. Now pay attention, you've got to keep that negative with it. So negative 3y to the 5th. All right, so they told me to use the 3 and the 5. I already knew that. Now, I need to double check. 3 plus 5 gives me 8. That works. And this is, just part of the sum, right? I've got other numbers on both ends. But now I can also get the coefficient, because I'm going to take the coefficient, the n, which you already know is 8. And then this number down here is going to be what? Do you remember from the last time? It's going to be this value. So that is 5. So now when I do that combination of 8 and 5, okay, I'm going to type in 8. I hit math, go over to probability, select the combination, and type in 5. And it will do the factorial work for me, and it tells me that that is 56. So I have 56 times, what is 2 cubed? That's 8x cubed. Now I have a negative 3 to the 5th power. All right, I'm going to start putting these in parentheses. That'll be a little easier. Negative 3 to the 5th power. That is a negative 243 y to the 5th power. Now I need to multiply 56 times 8 times negative 243, and I get negative 108,864, and then I have still my x cubed and my y to the 5th. But it didn't care about that, right? All I want is this coefficient. This time, if you have the a and the b aren't just an a and a b, like they were up here, for example, 3, you have to expand that. Now, let's represent this with sigma notation, and I'm running out of time. I have less than 30 seconds. So I think what I'm going to do is do that part in class when you come, as well as an application problem on your homework. So this is something we will do when you come, and I will see you then. Thank you.